Hello, this is question 2 on June 2019 mechanics paper, so AS paper. And you have a pulley question. So you have small ball P, which is this one. The mass is 0.8 kilograms, is held at rest on a smooth horizontal table and is attached to one end of a thin rope. The rope passes over a pulley that is fixed at the edge of the table, and at the other end we have this mass Q, which is 0.6 kilograms. Then P is released from rest with the rope taut, and P at a distance of 1.5 meters from the pulley, this distance here, and Q 0.4 meters from the floor. Yeah. Ball P descends, hits the floor, and does not rebound. So this goes down, hits the floor, and stops here. The balls are modeled as particles, the rope light and extensible, and the pulley is small and smooth. Using the model, we have to find the acceleration of Q, yeah, when falls, so this one, which is going to be the same as the acceleration of P. So the first thing we are going to do, and always we do the same with these pulley questions, is to represent the forces that are acting in both particles. So in this one, I have the weight pointing down, and it's going to be 0.6 times gravity, and the tension up. Then this is going to go down with an acceleration A, and we need to find that acceleration. And the other pulley, the other particle, I have a tension pointing away, is what is moving it. Weight, which is 0.8 G, and normal reaction, that is, I'm going to call it R. We are not going to need this, any of them. I'm just going to represent them so you know all the forces that are acting. But the particle is moving in this direction, so we are only working with the forces in this direction. We don't have friction, so this is all that is happening here. This particle is moving with the same acceleration. And this tension are the same. Then, to find the acceleration, we are going to do always the same. We are going to write an equation of motion for this particle and an equation of motion for this one. We will have two unknowns, T and A, and we will just eliminate T to find A. So I'm going to do that. So for A, I'm going to write an equation of motion for P. I'm going to write the resultant force is mass acceleration. So my resultant force here is just T, is my only force acting in the direction of the motion. So T is going to be mass, which is 0.8 times acceleration. So for P, my equation is, I'm going to write here, T is the mass times acceleration. And for Q, I'm going to apply again the same equation. Is moving down, that means that this force is greater than this one. So my resultant force is 0.6 G minus T is the mass, which is 0.6. So 0.6 G down minus the tension up is going to be the mass, 0.6 times acceleration. So these are my equations of motion for P and Q. To find the acceleration, I just have to eliminate T. So for example, I can add the equations because that way I have T and minus T. So if I add them, left hand side I have 0.6 G, and right hand side I have 0.8 A plus 0.6 A is 1.4 A. Therefore A is just 0.6 times 9.8 divided by 1.4, which is the 4.2 that we needed to find. Yeah, so quite quick question. And we are going to do always the same with connected particles. If they ask the tension, we can find it easily from here, or from here. This one is just simpler. Then B, they say find the time taken by P to hit the pulley from the instant when it's released. So we need to find the time that takes for this particle to move this 1.5 meters. Yeah, when we have questions about time or velocity or distance in a pulley question, we have to think in constant acceleration. So it's going to be a Subat equation question. So for B, I'm going to apply Subat. But you have to think that this particle is moving like in two different ways. So the first 0.4 meters, while this one reaches the ground, is accelerating with 4.2 meters per second squared. Yeah. After that, it keeps moving up to the pulley. But we have to think that when this particle hits the ground, the string, the rope, is not anymore taut, so it loses the. It's like if I have not anymore the string, so this tension is not here. That means I don't have any force in this direction, so it means the acceleration is zero, and if the acceleration is zero, it's constant velocity. Yeah, so I have accelerated part of the motion for 0.4 meters, and then the rest is going to be constant velocity. So I'm going to find the time of this part and this part. So the first one, I'm going to apply subad because I know it's constant acceleration. I know the acceleration is 4.2. The displacement is the 0.4 first meters. Initial velocity is 0. It starts from rest. We don't need this velocity, and we need to find this first time. Yeah, so I'm going to use an equation, a subad equation for my list without v, which is s is u t plus 1/2 a t squared. S is 0.4, u is 0, 1/2 a 4.2 t squared. We get one positive value and one negative value. We just get the positive one, so that means t rounded to two decimal places is 0.44 seconds. So that's what it takes for the particle to move the first 0.4 meters. Now, after that, it's moving with constant velocity. If it's moving with constant velocity, we need to find that velocity. But that constant velocity is going to be the final velocity of this bit here. So I'm going to use the same parameters, and I'm going to find this v, because this v is the one that is going to be constant after. For that, I'm going to use a subad equation that can be, it doesn't matter really. So v is u plus at. I could use any. V is going to be 0 plus 4.2 times the time that we just found. So this final velocity is 1.83, again round to two decimal places, meters per second. This is the constant velocity. For the second time, we know it's constant velocity motion, so velocity is going to be distance divided by time. My velocity is 1.83. My distance is 1.5 minus 0.4, so 1.1 meters, divided by the time that it takes. And from here I find the second time. So t2 is going to be 1.1 divided by 1.83, which is 0.60 seconds to two decimal places. So the total time taken is going to be this one here plus this one here. Yeah. So total time is t1 plus t2, which is 1.04 seconds. Yeah, that's B. The last thing they ask is state one limitation of the model that will affect the accuracy of your answer to part A. So it could be any of the assumptions that we've done. So for example, the balls are models of particles, or the rope is light, or is inextensible, or the pulley is smooth. You can mention any of them. So let's say, for example, rope is light. Yeah, rope is light. So any of the assumptions that you have done are really limitations for the model that will make your model less accurate. Yeah, but that's what you have to do to work with a model. You are doing assumptions. That's always the case. Yeah, so that's all with this exam question.